In the last lecture, you learned that switches, which function at layer 2 of the OSI stack, learn MAC addresses and use that information to populate the MAC address table, which is a mapping of the MAC address to the port that it is reachable on. In this lecture, we're going to take a look at how that works in a bit more detail with an example. So we've got one switch here. We've got a host with MAC address 1111.1111.1111 plugged into port 1. I've just written it in shorthand here as 1.1.1 to keep things a bit more simple. 2.2.2 is plugged into port 2 and 3.3.3 is plugged into port 3. Right now we've just powered everything on, so there's nothing in the MAC address table yet. Then the host on the left, 1.1.1, sends a frame in with the destination MAC address of 2.2.2. So the switch will see that. It sees a frame coming in with the source MAC of 1.1.1, the destination MAC of 2.2.2, so it learns that 1.1.1 is reachable on port 1, and it puts that information into the MAC address table. The destination of 2.2.2 is not in the MAC address table yet, so it's an unknown unicast address, so the switch will flood it out all ports apart from the one it was received on. So that will be sent out ports 2 and 3. That will be received by both hosts. The host 3.3.3 will see that the destination MAC address is 2.2.2. That's not it, so it will just silently discard the frame. The host of 2.2.2 in our example is going to send some traffic back. So it sends a reply from the source MAC of 2.2.2 itself to the destination MAC address of 1.1.1. That will hit the switch again. The switch will see that traffic has come from a source of 2.2.2 and it came from port 2, so it will put that information into its MAC address table. It will then send the frame out only port 1 because it sees that the destination MAC address is 1.1.1 and it knows that it's available on port 1, so it sends it out only that port. Okay, so that was how traffic works with a single switch. Now we're going to look at another example where we've got two switches. So switch 1 has got host 1.1.1 plugged into port 1 and 2.2.2 plugged into port 2, and switch 2 has got host 3.3.3 plugged into port 1 and 4.4.4 plugged into port 2. And the two switches are connected to each other using port 24 on both switches. Again, we've just powered everything on, so there's nothing in the MAC address table on either switch yet. Then host 1.1.1 sends a frame in with a destination MAC address of 2.2.2. Switch 1 will learn that 1.1.1 is available on port 1 and it will put that information into its MAC address table. It will then flood the frame out all ports because it's unknown unicast. It doesn't know where 2.2.2 is yet. So that will get sent out both port 2 and port 24. When it comes into switch 2 will do the same thing. It will flood it out all ports, so that will be sent out port 1 and port 2 as well. The hosts 3.3.3 and 4.4.4 will see that the destination MAC address is 2.2.2. That's not for them, so they will silently drop the packet. While that is happening, switch 2 will update its MAC address table because it learned that 1.1.1 was reachable through port 24 because that's the port that the frame came in on. The frame will have reached 2.2.2. In our example, again, it's going to send some return traffic, so that will hit switch 1 with a source MAC of 2.2.2 and a destination MAC address of 1.1.1. Switch 1 will update its MAC address table with the entry for 2.2.2 to say it's reachable on port 2. Switch 1 will then forward the frame out port 1 because it already knows that MAC address of 1.1.1 is reachable through there. It's in its MAC address table. Notice that the frame does not get sent down to switch 2 now because switch 1 knew that it should go out only on port 1. The next thing that happens is we're going to have some different traffic. So now the source of 3.3.3 sends a frame to destination MAC address of 2.2.2. That hits switch 2 and it will update its MAC address table to say that host 3.3.3 is reachable on port 1. Switch 2 will then forward that frame out all ports because the destination MAC address was 2.2.2 and it doesn't have that in its MAC address table. So it's unknown unicast, it will send it everywhere. That will hit switch 1 and switch 1 will see the frame arriving on port 24 that came with a source MAC address of 3.3.3, so it will put that information in its MAC address table. It will then send the frame out port 2 to the destination of 2.2.2 because it already had that in its MAC address table. It just sends it out that one relevant port. Then host 2.2.2 sends some return traffic back to the destination MAC address of 3.3.3 and that hits switch 1. Switch 1 does have 3.3.3 in its MAC address table. It sees that it's reachable through port 24, so it sends out just that port. The traffic will then hit switch 2. Switch 2 sees traffic coming in from a source MAC address of 2.2.2 on port 24, so it will update its MAC address table with that information. It will then forward the frame out port 1 only because it knows that 3.3.3 is available out that port. And if you look at the MAC address table for switch 2 now, you can see that 1.1.1 and 2.2.2 are both reachable on port 24. And this is what you'll see in normal practice as well. Where a switch has got a single end host plugged into it on a port, then it will just have that one MAC address on that port in its MAC address table. But where a switch is connected to another switch, you'll see there will be multiple MAC addresses reachable on that port. Okay, that's it. That's what I wanted to show you there. You now know how switch operation works, both for a single switch and in a multi-switched campus.